Hello, exceptional students of Mrs. Whitney's. Welcome to Scale Drawings and Models. By now you should have watched Brenna and I believe Mr. Whitney talking about how we use scale drawings and models, both in model trains and in architecture. So a scale drawing is a proportional two-dimensional drawing of an object, and a scale model is a proportional three-dimensional model of an object. That really funny rain catcher that you guys see in my room is a scale model. So scale is the measurements in scale drawings and models are proportional. Anyway, let me explain it in real words. So if you have a scale, you'll see it at the bottom of like this. Where'd my cursor go? There we go. This shows 1 centimeter to 50 miles. So what that is a scale. And scale is always the model or the drawing over the actual. And I'm sorry, Brita I think that's Brita. Yep, that's Brita. She's chewing on her bone. So in this case, in this map, it is 1 centimeter for every 50 miles. So if there is a on this map, if you took a ruler and measured and got a centimeter, so let's just say for the sake of argument that it's 1 centimeter from here to here, it means that it's actually 50 miles in real life. So we're going to look at what's the actual distance between Cadillac and Detroit. And Cadillac is right here. And Detroit is right here. And in the book, if we took out a ruler and measured it, it would be 3 5/10 of a centimeter. So we use proportions to figure this out. So we take the scale, which is 1 centimeter, for every 50 miles. And then we set up the proportion. And remember, you've learned that proportions, you're comparing like things to like things. So if it is 3.5 centimeters from here to here, it goes in the numerator because you are comparing. It's one of the reasons why I like to leave the units on this. It helps you decide whether it goes in the numerator or the denominator. And we don't know how many miles it is, so that's our variable. And so we cross multiply. 1 times x gives me x. And 3 5/10 times 50 gives me, let me quickly do that on a calculator. 3 5/10 times 50 is 175. So my answer is 175 miles. See if I can get, there we go, miles. So set up the proportion. The scale goes here, and then what you're looking for goes over here. Please use the proportion to figure things out. And use the units to help you decide what goes where. All right, so scale can be written without units when the units are the same. The value of this ratio is called a scale factor. So like in the trains with Mr. Whitney, the scale factor is 1 to 1/87th. So it means 1 inch is 1 inch on a model is 87 inches on the real thing. 1 centimeter on the model is 1 centimeter, or 87 centimeters on the real thing. So scale factor describes the multiplicative relationship between the dimensions of the scale drawing or model to the actual thing. So we can actually figure out what a scale factor is. So we're looking for the scale model of Sergeant Floyd Museum is 10 inches tall. So we know that it is 10 inches to 100 feet. So they're saying, what does 1 inch represent in the model? Well, 1 inch in the model, 1 inch is 10 feet. So, but we're looking for the scale factor. The inches in feet, we need to have those to be the same. So if I have 1 inch and 10 feet, I still want that to be 1, but I either both of these to be inches or both of these to be feet. It's easier to multiply it by, let's see here, 12 inches is 1 foot. And the way I figured this out is kind of like when we had, 2x over 2, the 2's canceled out because they became 1. When you're figuring this out, the inches actually cancel out because they're divided by each other, and the feet cancel out because they're divided by each other. And the reason I can multiply 1 foot over 12 inches is because it's really 1, right? You can multiply anything by 1, and you get the same answer back. But a ruler is 1 foot, or it's 12 inches. It's the same thing. So I'm really multiplying by 1, even though the numbers are different. It's kind of a tricky thing. But you got to think about it like that. So I multiply 1 times 1, and I get 1. So it's 1, and there's no units left because the units canceled out. And then 10 times 12 is 120. And so it's my scale factor. So for every 1 foot, it's 120 feet on the real thing. So that's your scale factor. Okay, so modeling in real life. The scale drawing of a computer chip helps you see the individual components of the chip. So this is actually, normally you think about having a model being smaller than the real big thing, but this is actually a case where the drawing is larger than the real thing because the real thing is teeny tiny. So our scale over here is, and I'm going to write this is the drawing over the actual, just so that we can kind of remember that. And so in this case, it's 1 centimeter in the drawing for every 2 millimeters on the actual chip. So we're going to find the perimeter in the area of the computer chip in the scale drawing. So I think we actually have to measure that, and I don't have a ruler. So I'm going to say that that is roughly 1, 2, 3, 4. Or you know what? We're going to say that that is 5 centimeters. I'm just making stuff up now because I don't have a ruler. So to find the perimeter in an area of the computer chip in the scale drawing, I just used a ruler, wink, wink, and the perimeter is the length plus the length plus the width plus the width. And so that's 5. And this, by the way, we're going to say this is also 5 centimeters because it's a square. So 5 plus 5 plus 5 plus 5 is 5, 10, 15, 20. So it is 20 centimeters. And the area is length times the width. So that is 5 times 5, which gives me 25 centimeters squared. Remember, these are additive, so they're just centimeters, and this is multiplicative, so it's centimeters squared. Okay, so now I want to find the actual perimeter and area of the computer chip. So I'm going to use the scale factor, or the scale, sorry. So if I know I have 1 centimeter over 2 millimeters, and I know that it's 5 centimeters, because I measured it, wink, wink. So I cross multiply, and I end up with 10 millimeters. And since this is a square, all the sides are the same. So the perimeter of the actual is 5 plus, let's undo that, is 10 plus 10 plus 10. So 10 plus 10 plus 10 plus 10 would give me 40 millimeters. And the area is length times width, and that is 10 times 10, or 100 millimeters squared. So it says compare the side lengths of the scale drawing with the actual side lengths of the computer chip. So we know that it is 5 centimeters per 10 millimeters. So that's the actual. Thanks for watching.